In this tutorial, you will learn to create a full-stack web application from scratch using SQLite DB for the database, Python Django for the backend, and React.js for the front end. We will first start with creating the backend project with Django and create the required REST API endpoints. And then we will use React.js for creating the front-end project. You will learn how to add routing for our app. Create Bootstrap table with custom sorting and filtering capabilities. Add modal pop-up windows with drop-downs and date pickers. We will also learn how to upload an image and store it in the backend server. Welcome to the course and happy learning. Let's install Python. We will be installing Python from the official website. Also choose to add Python to path. Let's verify the installation from command prompt. The installation was successful. Let's install Visual Studio Code. Visual Studio Code is a popular lightweight code editor from Microsoft. It is mostly used for front-end web development. Let's install Postman. We will be using Postman to test our REST APIs. Let's download SQLite Studio, which we will be using to manage Sqlite Database. We don't have to install to use it. We just need to open the executable file to use SQLite Studio. We can add the necessary database to manage it. Let's install Node.js. To verify the installation, we can just check the npm version. Let's install the necessary modules needed for our Django project. First, let's install the Django module. To create REST APIs, we need to install Django REST Framework. By default, the Django project comes with a security that blocks requests coming from different domains. To disable this, let's install Django CORS Headers module. Now let's create the Django project. Open the command prompt in the desired folder and type the command. Django admin start project and the name of the project. Let's open Visual Studio Code inside the project path. Let's take a look at some of the important files in the project. init.py file is just an empty file that indicates that the given folder is a Python project or a Python module. asgi.py is the entry point for the ASGI-compatible web servers. wsgi.py is the entry point for the WSGI-compatible web servers. urls.py file contains all the URL declarations needed for this project. settings.py file contains all the settings or the configurations needed for the project. manage.py is a command line utility that helps interact with the Django project. Let's simply run the project and see how it looks in the browser. Just type python space manage py space run server. The app is now running in the port 8000. Let's copy the URL and open in the browser. What you see on the screen is the default template that comes with every Django project. Now let's create an app in our Django project. Quick difference between projects and apps. The folder structure that you currently see on the screen is called the project. A project may have multiple apps. For example, you can have one app which acts like a blog, or maybe another app which acts like a survey form. Currently, this project does not have any app. Let's create one app to implement our API methods. To create an app, we need to type this command: python space manage.py space start app space the name of the app. Next, let us register the app and the required modules in settings.py file. In the installed apps section, let's add REST framework, CORS header, and the newly created app. We need to add the CORS headers in middleware section as well. We will also add instruction to enable all domains to access the APIs. This is not recommended in production. Instead, just add only those domains that needs to be whitelisted. Let's create the models needed for our app. We need two models, one to store department details and another one to store employee details. The department's model will have two fields, one to store an auto-incremented department ID and another one to store department name. Employee model will have 5 fields: employee ID, employee name, department, date of joining, and photo file name, which stores the uploaded profile picture file name. Now let's create the tables from these models. We will be using the default SQLite database that comes with our Django project. We can see that it is already registered in the database section of settings.py file. Let's open up SQLite Studio and see what the database looks like. We see that currently there are no tables in it. Let's write the command to make migrations file for our models. After executing this, we can see a migration file which tells us what changes to the database will be done. Once it looks fine, we can execute the command to push these changes to the database. Let's now refresh the database. We see that the database tables are now created. Let's run select query on them. We see that currently we don't have any data. Let's insert some record into it. Let's create serializers for our models. Serializers basically help to convert the complex types or model instances into native Python data types that can then be easily rendered into JSON or XML or other content types. They also help in deserialization, which is nothing but converting the past data back to complex types. Let's now start writing the API methods. Open view.py file. We are importing CSRF decorator to be able to allow other domains to access our API methods. We need JSON parser to parse the incoming data into data model. Let's import the models that we created. And also the corresponding serializer classes. Let's write our API methods for departments table. The method will receive an optional ID which we will need to use in the delete method. In get method we will return all the records in JSON format. We are making use of serializer class to convert it into JSON format. The parameter safe equal to false is basically used to inform Django that what we are trying to convert to JSON is actually a valid format and we are fine if there are still any issues in it. Let's write post method which will be used to insert new record into departments table. We are parsing the request and using the serializer to convert it into model. If the model is valid, we save it into the database and return success message. Next, let's complete the put method which will be used to update a given record. First, we are capturing the existing record using department ID. Next, we are mapping it with new values using serializer class. And save it if the model is valid. Finally, let's implement the delete method. We will be passing the ID to be deleted from the URL. Let's now add routes to specify the URLs for our API methods. Add a new file urls.py. The delete method will receive ID in the URL. Next, we need to include these URLs in the main urls.py file. Now let's test our API methods. Let's first start the project using the command python space manage.py space run server. Let's test get method, which returns all data from the table. We see that get method works as expected. Let's test the post method to insert new data. The post method also works, and we can verify it by calling the get method again. Let's test put method and update a record. The put method also works as expected. Finally, let's test the delete method. The delete method also works as expected. Let's now implement the API methods for employee table. Let's add the URL routes as well. Let's now test these APIs. We see that the employee API methods also work as expected. Let's add an API method to save the uploaded profile picture. To store the images, let's first create a folder in our app. To be able to use this folder, we need to add some instructions in the settings.py file. Now let's add the API method. We are making use of default storage module to save the file. Once it is saved, we simply return the file name. Let's add a URL route for our API method. Let's now test the API method by uploading a file. We see that the upload file API works as expected. Let's create our React.js project. Open up command prompt in the desired folder and type the command npx create React app and the name of the app. Let's navigate inside the project and open up Visual Studio Code. Let's simply run the project and see how it looks. Just type npm start. What you see on the screen is the default template that gets added when we create new project. Index.html is the file that gets finally rendered on the screen. Observe that it has a div with ID root. In index.js, we can see that the contents of our app component is injected into the div with ID root. So app.js is our root component and what you see on the screen comes from this file. Let's delete the content and add an heading tag. Let's install Bootstrap for styling. Copy the style sheet reference and add it in the head section. The bundle reference can be added near the closing body tag. We see that our heading with Bootstrap styling is getting displayed. Let's start adding the routing for our app. We need to install an npm package called React Router DOM to add routing for our React app. Now let's add the components or the pages for our app. We will need 3 components. One for homepage, one for department details, and another one for employee details. Let's add contents in home component. The HTML can be defined in render method. Let's add similar content for department and employee component. Now let's add the navigation menu with routing. Let's import all these components. Also, let's import the modules needed for routing. Now let's add the navigation menu. In the switch tag, we can define the route paths. /home will be routed to home component. /department for department component. And /employee for employee component. Let's start the app and check if this works. We see that the routing works as expected. Let's create a file to store our API endpoints. Let's import it in the department component. Let's create a constructor to define the state variables. The super props is basically used to call the constructor of its parent class. In state, we will be defining an array called departments which will be populated with the department's data from API. Let's now add HTML to display departments data in a Bootstrap table. We will be using map method to iterate and display data. Along with department ID and department name columns, we will also have options column to edit or delete records. Let's add Bootstrap icons for edit and delete. Now let's add the method to refresh the department's data from the getAPI method. Once the response is available, we convert it to JSON and assign it our array. We will call the refresh method once the component is mounted. We need to also declare the state variables in render method to use it inside HTML. We see that the table now displays data as expected. Let's add the modal pop-up window with form fields to add or edit departments. Let's define the variables that we are going to use in the modal window. Now let's add the HTML code for Bootstrap Modal window. The title of the modal will come from variable. We will have one text box to add or edit department name. When the value of the text box changes, we will execute a function and update the variable simultaneously. We will have a button to create new department. This will be visible when user wants to add new department. The update button will be visible when the user wants to edit a department. Now let's add a button to open the modal window. This will be to add new department. Similarly for editing department. In the add_click method, we set the modal title to add department, department ID to 0, and department name will be empty. In the edit click, title will be edit department, and department ID and name will be based on the row data. We see that the modal windows works as expected. Now let's add the methods to create new department by consuming the postDepartment method. We are going to pass the new department name as JSON in the method body. Once successful, we display the message and also refresh the grid. Let's test the method by adding new department. We see that adding new department works. Let's now add the update method by consuming the putAPI method. Let's test it by updating a record. Also, let's implement the delete method. We will be taking user confirmation before deletion. Let's now test the delete method. The delete method also works as expected. Let's now complete the employee details screen. We are going to copy the department component and make changes to it. We will store the data in employees array. In the form fields, we need employee ID, employee name, department, date of joining, photo file name, and the path to photos can be taken from variables file. In refresh method, we are going to refresh both employees and departments array. We are going to use departments array in dropdown. In the modal window, we need to display profile photo as well. So let's use Bootstrap Flex. The image source can be computed from the variables. Department field will be dropdown. The values for dropdown will come from department's array. Date of joining will be a date field. We see that the grid and pop-up window for employee screen works as expected. Now let's implement the method to upload photo. Let's add a button to choose the file input. In the upload method, we will create a form data and attach the first file which was chosen. Once uploaded, we replace the photo file name variable. Now let's test our methods. Let's add a new employee. This seems to work. Let's test the put method and update a record. The put method also works. Let's now test the delete method. We see that the delete method also works as expected. Let's implement the sorting and filtering feature to our grid. We will implement it to the department details page. Let's first create variables to accept filter inputs from user. Also another variable array to store the backup or data without filter. Let's now implement the filter function. We will be using the includes built-in function to check and filter the array. Let's add the text box to accept user inputs for filtering. Once the value in text box changes, we update the filter variable and call the filter function. We see that the filtering works as expected. Let's now implement the sorting function. We will be sending the property name and a Boolean value which indicates whether to sort by ascending or descending. Let's add icons for calling the sorting function. Let's test the feature. We see that the sorting also works as expected.